This is a video about polar coordinates. There are two coordinate systems that are prevalent in two dimensions. The first one is rectangular coordinates given by the ordered pairs x and y. These are the ones that most of us are familiar with. In this rectangular coordinate system, 0, 0 is the origin, and x is the horizontal distance moved from the origin, y is the vertical distance moved from the origin. We're going to do a similar thing with polar coordinates, giving an ordered pair, but instead of x and y, we're going to have r and theta. 0, 0 is going to be known as the pole for this coordinate system, and r will be the distance from the pole along the terminal side of an angle theta, where theta is in standard position. So if we have an angle theta, then we'll just move r units away from the pole along that angle theta. We'll see an example next. So here's a grid that's set up with polar coordinates. You'll notice that we have these circles that tell us the distance from the pole. So 1 unit away would be the circle radius 1, 2 units away, circle radius 2, so on and so forth. We also have all of these angles, pi over 6, pi over 4, pi over 3, and as well as all the others all the way around. So if we want to graph a point, right now we have r is 5 and theta is pi over 6. So that means we go to the pi over 6 ray right here, and then move 5 units away from the pole. If we want to graph the point, let's say 3, 2 pi over 3, then we go to the pi over 3 ray, and then 3 units away. So 1, 2, 3 right there. So there's the point 3, 2 pi over 3. And you can do that for any angle. So if we want to know what the coordinate is of the point down here, here's the point. R is 7, theta is 5 pi over 3. Now if I show the rectangular coordinates, you'll notice that uh, this x and y are also given. So I can have an x and a y for an r and a theta. And we'll look at converting these later. But just notice that the points are in the same plane, and we're not really changing anything other than the names. So with positive r's, everything is pretty easy. So here's another graph where I can change my r and my theta. So here's the point 2, 5 pi over 3. But if we make r negative, an interesting thing happens. So I'm going to change this angle over here to one that we're familiar with. So here's the point 2 pi over 3. And now if I make my r negative, notice what happens. So making r close to 0 takes us to the pole, and then negative r's will take us in the opposite direction of our terminal side. So the point negative 2 3/4 pi over 3, that'll just take us that distance away from the terminal side pi over 3. So let's try the following. Negative 3 pi over 4. So that means we need to go, I'll make this r positive for a minute. So we need to go to the angle pi over 4. So there's pi over 4 along that purple line in quadrant 1. And now we're going to go negative 3 units. So negative 3 units will just take us the opposite direction into quadrant 3. So there's the point negative 3 pi over 4. If I want to try the point negative 2 pi over 6, again, I'll just go to angle pi over 6. So that would be along this brown line in quadrant 1. And then if we're going to move a distance negative 2, that'll take us negative 2 units away from that terminal side. So that'll be negative 2 units in the direction of quadrant 3. So away from that pi over 6 ray. Another one, negative 4, 5 pi over 3. So let's make this r positive again and find our angle. So our angle 5 pi over 3 will be all the way around here in quadrant 4. And now we're going to go a distance negative 4. So now if we move negative 4, that's going to take us back into quadrant 2. Negative 4 units. So there's the point negative 4, 5 pi over 3. So we'll do several conversions with polar coordinates. The first one we're going to look at is polar to polar formulas. So points in polar coordinates do not have unique names. This is unlike the XY coordinates. A point given in XY coordinates or the rectangular coordinates will always have a unique name. One point gets one name. In polar formulas, or in polar coordinates, that is not the case. We might have several names for the same point. So here are a couple of formulas. R theta is negative R, theta plus or minus pi. We'll see why that's true in a second. And R theta is R with theta plus or minus 2 pi. All right, so why would that first one be true? R theta is negative R plus or minus pi. So if I take my theta to be, let's say, 3 pi over 4. Well, what I can do is I can make my R negative. So instead of positive 3, I'll make it negative 3. But then to get back to the same place, I'm going to either have to add pi or subtract pi. So if I subtract pi, I can see I'm taken to the same place that I was before, over there in quadrant 2. So let's look at this second formula. So R theta plus or minus 2 pi. So if I take this negative pi over 4 and I want to add 2 pi to that, I'll just be taken all the way around till I get here to 7 pi over 4. So there's the point negative 3, 7 pi over 4. If I want to change my R to positive 3, there's the point 3, 7 pi over 4. I can subtract 2 pi. That takes me all the way around the circle till I get to negative pi over 3. So in this way, I can make lots of different coordinates just by adding or subtracting 2 pi to my angle, or adding or subtracting pi and making that R negative. So here's an example. The point 3, 5 pi over 4. So let's go to that one. So I have R is 3 already. And now I'm going to go to the angle 5 pi over 4. So that should be over here in quadrant 3, if I can get on it. So there's 3, 5 pi over 4. Now if we want to subtract 2 pi from that, that should take us to the same place. So if we subtract 2 pi, negative 3 pi over 4 will be our angle. So that's all the way back around again, now at negative 3 pi over 4. R is still 3, but the theta is negative 3 pi over 4. So there's our point in quadrant 3 again. The negative 3 pi over 4, now we're going to add pi to negative 3 pi over 4, so that takes us to pi over 4. So that's halfway around, and then we'll make our R negative. So now that negative R takes us back to quadrant 3 again. So there's the point negative 3 pi over 4. All of those are in quadrant 3 in the same location. So you can see there's 3 different representations there for the exact same place in our coordinate system. Now this will be a powerful tool when we get to graphs, and we'll see that we can have overlapping lines, things that cross through the same point, just because there are several different names for the exact same location. So this will take us to the end of this video, and then next time we'll look at switching from rectangular to polar and vice versa. So here we want to find 3 other polar names for 2, negative 7 pi over 6, with the restriction that our angle has to be between negative 2 pi and 2 pi. So one way to find another point that's in the same location is just to add or subtract 2 pi to our angle. So since we have a negative angle, I'm going to try to come up with a positive one by adding 2 pi. So this 2 negative 7 pi over 6. We'll add 2 pi to the negative 7 pi over 6. And that'll be negative 7 pi over 6 plus 12 pi over 6. So that gives us 5 pi over 6. So there's one point, 2, 5 pi over 6 in the same spot. We can also change our angle by adding pi and then making the R negative. So we'll also do that. So this 2 negative 7 pi over 6, we can change the R to a negative 2 and go halfway around. So only add pi. So negative pi over 6. Negative 7 pi over 6 plus pi will give us this negative pi over 6. So we got 2 points, 2 5 pi over 6, negative 2 negative pi over 6, both in the same location. And then we need one more. They asked for 3 polar names. So now we'll just take one of these two and add 2 pi again. And usually it's going to be the one that we don't have. So we already have 2 with a positive r, and we're going to need 2 with a negative r. So we'll take that last point that we found and just add 2 pi. So the negative 2 negative pi over 6 is going to be negative 2 negative pi over 6 plus 2 pi, which gives us negative pi over 6 plus 12 pi over 6, which is 11 pi over 6. So there's 4 points, 2 with positive r's, 2 negative 7 pi over 6, 2 5 pi over 6, and 2 with negative r's, negative 2 negative pi over 6, and negative 2 11 pi over 6. Go ahead trying to plot these on your own just to make sure that they are in the same location. So if you plot all of these points, you should end up in the same place. In our next video, we'll see how to convert from polar coordinates to rectangular coordinates and back from rectangular into polar coordinates.